Hello, welcome to Jeongbin study room. I prepared a topic today called RS nomenclature and cross product of vectors. What is the RS nomenclature? The most representative nomenclature for distinguishing enantiomers in a mirror image is the RS nomenclature. Shall we explore it together in more detail? Isomers refer to compounds with the same molecular formula but different arrangements of constituent atoms in terms of bonding or spatial configuration. After the thalidomide disaster, mirror image isomers became an essential subject of study due to the significant differences in reactions they can cause within the body. Among isomers, those exhibiting asymmetry due to mirror image symmetry, namely chirality, are referred to as enantiomers. When a molecule's mirror image cannot be superimposed onto itself in a mirror, it is said to possess chirality. When a left-handed glove cannot be worn on the right hand, and vice versa, due to their mirror image symmetry but inability to overlap, and similar characteristics observed in certain compounds, the term chirality was coined. It originated from the ancient Greek word chir, meaning hand. When classifying such chiral substances, the nomenclature based on the atomic numbers of substituents is called the RS nomenclature. When there is a chiral center with substituents around it, attention should be given to the substituents attached. By numbering them based on atomic numbers and placing the fourth element behind the chiral carbon, the remaining three are arranged in one plane. If these three elements rotate clockwise, it is designated as R form. If counterclockwise, it is designated as S form. On the other hand, what is the cross product of vectors? It is an operation that finds a new vector, perpendicular to two given vectors and following the right-hand rule. This operation is denoted by the cross multiplication symbol. Now, I would like to propose a new way of understanding the RS nomenclature method by connecting it with the cross product of vectors. The center represents the chiral center, namely the chiral carbon. The surrounding four atoms are labeled as A, B, C, and D, with the assumption that A is given the highest priority and B is assigned the second highest priority. Shall we differentiate between the R and S forms through the cross product of vectors? If C is assigned the fourth priority and D the third, the resulting cross product direction is similar to the direction of the third vector, indicating the S form. Conversely, if C is third and D is fourth, the direction is akin to that of the fourth vector, signifying the R form. Shall we look at it in terms of the shapes of the atoms? Has it become a bit easier to understand? Perhaps if you try it yourself, it will be much easier to grasp. Today, I introduced a method of distinguishing the R and S forms using the cross product of vectors. How was it? If you want to learn more, please follow the link in the comments. I'll be waiting for you in Jeongbin study room.